Good morning, everyone. I hope everybody had a great Easter weekend and got some rest and caught up on some things. Today, what we're going to look at area on the coordinate plane. And I've got a couple of example problems for y'all to check out before you get started on your work. The first question we've got involves finding the area of an irregular object. And this actually does pertain towards some ideas that you'll be looking at in pre-cal and in calculus. This kind of helps prepare you for that. Now, what I would do if I had a problem like number one is that I would actually divide this up into either rows or columns. I kind of prefer to look at columns just because later on when you get into pre-cal and calculus, you're going to be finding the area underneath a curve. And you'll be using this same idea or same method. So what I'm going to do is I'm going to divide my shape up into columns for each one of the sections on the grid. And so I'm going to take my pen and I'm going to draw vertical lines right on my grids. I could go across too. That would also give me a pretty accurate estimate. But now I'm going to look at each one of these different columns. I'm going to estimate about how much each column has an area. So on this first column, I'm counting, I've got 1, 2, I could take this little part, fill it in there. That would be a total of 2. So I'm going to estimate right at 2.4 for the area of that first column. On the second one, I'm going to take a little bit off here. 1, 2, 3, and a little more, so maybe 3.2. Okay? Third column, 1, 2, 3, about 3.8. Okay, next column, 1, 2, 3, 4, 5, 6, about 6.8. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 8.6. And again, I'm trying to get as close as I can, but I know that I'm having to round off some. We're just trying to get a good estimate. Okay, on this column, 1, 2, 3, 4, 5, 6, 7, 8. 8.6 again. Okay. Looking at this column, I'm going to estimate at 1, 2, 3, 4, 5, 6, 7.2. And I'm taking this little part in here. I'm adding in a little bit from this top one. So 1, 2, 3, 4, 5, 6, 7, and there's just a little bit extra over that, so about 7.2. Okay, this column, I've got this little bit down here. We could add it up here. So 1, 2, 3, 4, 5.1. And then on this last column, I would say there's about about 2.5 again. Now, the next step is we just add up the estimated areas for each of our columns. So I'm going to write it vertically just to help me keep things straight. I've got 2.4, 3.2, 3.8, 6.8, 8.6, 8.6, 7.2, 5.1, and 2.5. And we're going to add all of those up. And I do have my calculator over here. I could use it. So let's see. Get our screen turned on. And we'll add those. 2.4 plus 3.2 plus 3.8 plus 6.8 plus 8.6 plus 8.6 plus 7.2 plus 5.1 plus 2.5. And that gives me a total of 48.2, and we'd say that's in units squared. Okay? And remember, since we are working with area, we do need to work with square units. Okay, so that's the first example. And again, later on, you're going to be working with graphs, and you're going to be asked to find the area underneath the curve. You'll be using a method very similar to this whenever you are working on those types of problems. So this kind of leads into that. The second question that I've got an example of has to do with perimeter versus area of these two figures. And so as far as finding the area or the perimeter, I've got 3 on this side. And 1, 2, 3, 4, 5 on this side. For the perimeter, though, I need to find the length of this hypotenuse. So we could always do our Pythagorean theorem. 3 squared plus 5 squared equals c squared. And so that'd be 9 plus 25 equals c squared. Or 34 equals c squared. So c is the square root of 34. That means our perimeter is equal to 1, 2, 3 plus 1, 2, 3, 4, 5 plus the square root of 34, which is 8 plus the square root of 34 units. Now, on our second figure, if you look at that, I still have basically the same hypotenuse. So this side is the square root of 34, just like over here we had the square root of 34. And if I count going across the units, I've got 1, 2, 3, 4, 5, 6, 7, 8. So again, our perimeter is going to be equal to 8 plus the square root of 34. Again, the reason that I have the 8 is because I counted up 1, 2, 3, 4, 5, 6, 7, 8. And then I know my hypotenuse is the same as it was over here. So perimeter is exactly the same. 8 plus the square root of 34 units. Okay, now here's the interesting thing. we know the area is equal to 1/2 the base times the height for a triangle. Okay? So, in this case, if I take the area, that's going to be 1/2 of 3 by 5, which is equal to 1/2 of 15. Half of 15 is equal to 7.5 units squared. Okay, on this other figure, I basically have the same triangle outline, but how many square units are we taking away? We've got 1, 2, 3 that are taken out of the corner. So the area for this figure is going to be 7.5 for the area of the triangle, just like we have on the first one, minus 3 square units, which would be equal to 4.5 units squared. So in comparison, the two triangles, or the two figures, have exactly the same perimeter, but the area of the second one is 3 units less than the first. Alright, I hope this helps. I will give the assignment to go along with this, but you actually have 2 days to work on this assignment. So, I hope that everything's going well for you guys. If you need anything, please contact me at my email address, and I will get back to you as soon as possible. Alright, thank you so much. Talk to you soon. Bye.